this way.
Oh, I'm so glad we ran into you.
This way.
Oh, I'm so glad we ran into you.
The station is right through here. After you.
Joy.
What?
Well, I read about this place in the manual. We shouldn't go in there.
Bing Bong says it's the quickest way to headquarters.
No, but Joy, this is abstract thought.
What are you talking about? I go in here all the time. It's a shortcut, you see? D-A-N-G-E-R, shortcut. I'll prove it to you. Look at me. I'm closer to the station because I'm taking the shortcut.
Let's go around. This way.
Almost there.
If you want to walk the long way, go for it. But Riley needs to be happy. I'm not missing that train. Bing Bong knows what he's doing. He's part dolphin. They're very smart.
Well, I guess.
What did you get?
Okay, what abstract concept are we trying to comprehend today?
Loneliness.
Looks like there's something in there. I'm gonna turn it on for a minute and burn out the gunk.
What'd I tell you? You'll be at headquarters in no time.
Oh!
Hey, would you look at that?
Whoa! What's happening?
No, they turned it on.
Never seen this before.
Ah!
My face! My beautiful face! Oh!
What is going
We're
on?
abstracting. There are 4 stages. This is the first. Non-objective fragmentation.
All right, do not panic. What is important is that we all stay together. Oh!
We're in the second stage. We're deconstructing.
Ah! I can't feel my legs! Oh, there they are.
Come here, me.
Ow! We gotta get out of here. Ow! Before we're nothing but shape and color. Ow! We'll get stuck here forever.
Doug, why do we come in here?
I told you! It's a shortcut!
The train!
Oh no! We're 2-dimensional. That's stage 3.
We're getting nowhere!
Depth! I'm lacking depth!
Come on! We can't fit!
Oh no, we're not figurative. This is the last stage.
We're not gonna make it!
Wait, we're 2-dimensional. Fall on your face.
Stop! Stop! No! You said there was a shortcut.
I did! But wow, we should not have gone in there. That was dangerous. They really should put up a sign.
How long to the next train?
Who knows? But there, that was dangerous.
It out. So it's like you remove one dimension from it. So can you imagine you take this cuboid or you take the tissue box, right? And then you and flatten it, it becomes 2-dimensional. Right? We will talk about 4-dimension again. But actually in the real science, 4-dimensional is something that's not understood well enough yet. 4-dimensional and above, it's not really well understood yet. Most of the theories that are coming out about the higher dimensions are all hypotheses. You know hypotheses? Yeah, are mostly hypotheses. Well, okay, so before we go on, do you see how they became 1D? It says 4 flat on your face. So from the actual one, it became one line. So that's how it became 1-dimensional. Okay, and then rightly pointed out last week, some of you say 0 dimension is like 1 dot. Yeah. So, yeah, so actually four-dimensional and beyond, there are a lot of hypotheses of it. That's why people can write stories and people can write a lot of interesting things out of it. Have you seen Doctor Strange before? Anybody know Doctor Strange? Anybody know Avengers? Yeah? And, oh, okay, cool. If you really go and study Avengers, not just read the comic or watch the show for its fighting and fun scenes, actually they try to write a lot of science in it. But actually half the science are not really true. But they make it sound really logical. Because in real world, if Mr. Spidey can't really climb wall, right? In the real world, Doctor Strange can't really turn anything, right? There's no real world that you can and push you into another right dimension. Never take your homework, you take the skill. Hey, I got you back. Right? But the different things to understand. So, yeah, of course, if you have gone to semester before, there's this big title that says 4D experience. You know, and when you went to universal students, 4D experience. You know, watch the Shrek, right? And you sit down there and watch Shrek with the 3D glasses. And then they go, what does this you? And they come to it. And then they say, that's so. I think it's like, he's not going to. I saw these additional sensations. Yeah. But when I take this, it's beyond what you're doing here. When you go secondary school or when you go up the higher level in mathematics and science, then you are really going to be able to talk about 4D and other dimensions with really lots of more sense. Yeah. Right? Which is very cool. So that's the purpose of why I'm showing you inside out thing. Okay, so back to here. This was homework yesterday. We are going to move on to the problems that we need to solve. So, just a reminder, please make sure you have the correct units. And then I forgot to bring my mic up. Can you still hear? Okay. So, when I find volume, area is 2 dimension, you realize. So when I talk about area, it's like talking about this face. Let's say I talk about this face here. This rectangular face is the area. That will be 15 meter times 8. It becomes volume when I okay. So it becomes volume when you add in another dimension. That's why the isometric grid comes in. You pull out another dimension to it. So area is just like this. So for area, you realize that is square meters. So it's 2 because you are meter times meter. Volume is when you times 3 different dimensions. The length, the breadth, and then the height. So 15 meters times 8 times 8. So your answer will have meter with a 3, meter cube, plus Length times breadth times height, meter times meter times meters. Okay? I leave you to solve it. We're going on to the problems now. Now, we'll see our next series of problems. Today, we are finishing up to, if I'm not wrong, 150 is the last page, right? Yes. Tomorrow, we are going to start with the new section on connecting liters, milliliters with cubic centimeters. And how does it make sense? And we'll be solving problems like talking about this kind of tanks. Fish tank, water bottle, this kind of thing. Yeah, we saw it before. So what's the greatest difference between these things? Like this problem here and this problem here. Yes. Okay, so well, that's very true. That's completely the point. They got it. So Achilles said the first difference is difference in units. Rightly pointed out. Why is there a difference with units? Ryan said because you go to the back, it's talking about the volume of water or volume of liquids inside a tank. And he said that in most stories, it's either a water point or water pump. Whereas, so what's the difference here? This one not water, then what is this? Solids, cubes and cuboids. Okay, that's the biggest difference. Now, let's try to solve the problems here. Because it's a little dry, we'll start from the last question. The last question here is this container. You realize that this container has been my tank. Okay, so previously we were in that group that had the tanks, right? Can you send one person up to take the tank? Take. Okay, now try to fill up the tank as how it's shown in the picture. I give her all my tanks already. Last week, who are you working with? Oh, because you're a different grouping. Those of you who have tanks, can you stand up? We are holding on to the tank. Okay. Any row that doesn't have a tank? You have or don't have? Don't have. Okay, never mind. We'll take turns at it. Sit down first. Okay, for those of you who have the tank, can you try out putting the cubes in like that? Found the answer already? So in this story here, the rectangular container is partially filled. Not full, but with some cubes as shown below. And then it says here, what is the volume of the container that is not filled? Meaning empty space. Huh? 120? How do you get that? Have you put in the cubes already? Huh? Almost, okay. Any group put in the cubes already? Come, can I have it? I wrote down a length, breadth, and height here. Length, breadth, and height of what? Anybody? The tank? Is it the tank? Huh? The entire volume of the tank. Okay, what else? Anybody put in already? Put in already, can pass me the tank. I show everybody how it looks like. Almost. Can bring it to me. Okay. Okay, come pass it to me. Okay, Amara's group has line up the tank like how it looks like in the book. Marianne's row, Akhilesh has helped. Now, there are two ways to do this. Method one. Like Jaren say, I could method one, find the whole tank, the capacity of the tank. Then minus the cubes inside. So that I get the empty space. Method two. Okay? So there are two methods here. I'm going to ask everybody which you think is a better method. Or which one you will choose. So, if it's the first method, find the whole tank minus the cube inside. So this is the tank. How do I find the whole tank? Length times breadth times height. So how long is this? How long is the tank? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 cubes long. How wide is the tank? 1, 2, 3, 4, 5, 6. Right? How tall? 3. 1, 2, and 3. So it's 3 times 6 times 9. So step number 1, I use 3 times 6 times 9. I find the tank, the whole tank. Then I need to minus the cube. How many cube? Have to count up. Count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42. Ayo, I must calculate so many things. Then I minus. Is there a shorter method? Yes. Okay, wait, I tell you what I think is a shorter method. I think the shorter method that everybody will be very fond of is find empty immediately. At one go, find the empty immediately. Is it possible? I don't want to find the whole thing. I just want to find the empty space. Immediately. Find the empty space immediately. Is it possible? How? Is it possible? Can you see there's some empty space here? Can you see that the empty space inside is also a cuboid? So I can fold another cuboid and then I try to stuff it inside. Okay? To see if it fits. So the empty space should be a cuboid that fits, right? What is that size of the cuboid? How long do you think is the empty cuboid? How long, long? Long. Okay. 1, 2, 3, 4, 5, 6, 7, 8. How wide is the inside cuboid? 5. 1, 2, 3, 4, 5. Yes. How tall is the inside cuboid? Still 3. Can you understand? I am not counting the entire space, just the inside. So the inside is only 8 times 5 times 3. So the volume of the empty space cm times 5 cm times 3 cm. 8 times 5, 40. 40 times 3, 120. Yeah. But you need to explain. Okay, wait. No. Now going to mother tongue already. Okay, we explain tomorrow. Now, hey! Now, your homework for these particular questions, I want you to tell me how long, how tall. How wide is already here? Okay? There's the homework for today. Move down. Your homework tomorrow, tell me how long, how tall. That's all. Okay? How long, how tall, how wide. Okay, bye-bye. Please return me my thanks. Yeah. Bye-bye. Sashay, no, Akhilesh, your cubes. I want it. Okay? I want it. 40 is 27, 15, and 10. 40 is 15, 10. 20, 10.